Vertex form, standard form, and intercept form of a quadratic function. The quadratic function y equals x squared has a graph that looks like this. It's a parabola with critical points of -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. It's going to be important for you to memorize these critical points. The axis of symmetry is the vertical line that passes through the vertex. It is also the line of reflection for the parabola. When we talk about domain and range, it's just like we discussed before. We want the interval from the lowest to the highest possible x value. So for the parabola, it's going to go from -infinity to +infinity. And then the range, our lowest to our highest y values. So it's from 0 to +infinity. When we talk about increasing and decreasing, we want the intervals where our function from left to right is going downwards versus upwards. So from -infinity up to 0, our function is going downwards. So we say that it is decreasing from -infinity to 0. And from 0 to +infinity, it is increasing. Now we use parentheses for our zeros for increasing and decreasing intervals because we don't know exactly what happens at that 0. Whether it's decreasing or increasing, we're not really sure. So use parentheses here. Vertex form of a quadratic is written y equals a times x minus h squared plus k. So some of these items you already know what they are. Finding the vertex is the coordinate point hk. K represents the vertical shift. If it's positive, you move it up. If it's negative, you move it down. H is the horizontal shift. Remember, it's opposite of what it looks like. So if it's plus in here, you're going to move it to the left, and if it's minus, you're going to move it to the right. There are two different ways that A is going to affect our graph. First, if it's greater than 0, it'll open upwards. Or if it's less than 0, it'll open downwards. The second, if A is greater than 1, it's a vertical stretch. And if its absolute value is less than 1, it's a vertical compression. The axis of symmetry, we said, is the vertical line that goes through the vertex. We find that with the equation x equals h. How do we find the x-intercepts, or the zeros, when an equation is written in vertex form? First, substitute y with 0, and then second, use the square root method to solve for x. Finding the y-intercept is going to be the point 0, f of 0, and remember f of 0 is the value for y when you substitute 0 for x into the equation. Now let's work out this example. So first, what I want you to do is have your table of values. This is where it's going to come in handy. And then we're going to take the a first and consider it like slope. I know it's not, but just consider it that way. 2 over 1, slope is rise over run. And remember, the rise affects the y-coordinate, run affects the x-coordinate. So we're going to take this 2 over 1 and you're going to multiply. Multiply all the y-coordinates by 2 first. 4 times 2 is 8, 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, and 4 times 2 is 8. Then you want to multiply all the x-coordinates by 1. Multiplying by 1 isn't going to change anything, so we'll just leave them. So these are our old y values. These are our new ones. Next, let's do the horizontal shift. We're going to do the opposite of the sign it looks like in here, so we're actually going to add 3 to each x-coordinate. Remember, horizontal changes the x value, so let's add 3. -2 plus 3 is 1, -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. These are our old x values, these are our new ones. And then lastly, we're going to do our vertical shift. It's going to be the same sign as what it looks like, so we're going to take all our y values, our vertical values, and subtract 2. 8 minus 2 is 6, 2 minus 2 is 0, 0 minus 2 is negative 2, 2 minus 2 is 0, and 8 minus 2 is 6. These are the old y values, these are the new ones. So lastly, what we're going to do is we're going to plot our new points. We have 1, 6, 2, 0, 3, negative 2, 4, 0, and 5, 6. And then lastly, we want to sketch our parabola. Then let's go ahead and fill in our chart. Our vertex is 3, negative 2. We had a vertical shift down 2, a horizontal shift to the right 3. Our axis of symmetry is x equals 3. Since a is greater than 1, it's a vertical stretch. Our x-intercepts are 2, 0 and 4, 0. And our y-intercept, we actually can't see our y-intercept on the graph here, so we're going to need to find it. So we need to substitute 0 in for x and we'll simplify the right side. So y equal to 2 times 0 minus 3 squared minus 2. So we have 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is going to be 18. 18 minus 2 gives us 16. So our y-intercept is going to be 0, 16. Our domain, negative infinity to positive infinity, and our range goes from negative 2 to positive infinity. It is increasing from 5 to positive infinity, and our parabola is decreasing from negative infinity to 5. Next, let's talk about standard form. This is what we've been working with recently, y equals ax squared plus bx plus c. So, again, a, if it's greater than 0, it opens upward, and if it's less than 0, it opens downwards. And here, our vertex is going to be the coordinate point negative b over 2a for the x-coordinate, and f of negative b over 2a for the y-coordinate. So again, that means f of negative b over 2a is the y-coordinate when you plug in negative b over 2a for x. The axis of symmetry is x equals negative b over 2a. In finding the x-intercepts, or the zeros, first we want to substitute y with 0, and then we want to either factor, complete the square, square root, or use the quadratic formula to solve for x. And we've been working on that. The y-intercept is 0, c. Let's work out this example. First, we need to identify a, b, and c, just like when we did quadratic formula. A is negative 1, b is equal to 4, and c is equal to negative 2. And then we want to find the value of negative b over 2a, because we're going to use this a few times in filling out our chart. So we have negative 4 over 2 times negative 1. That's negative 4 over negative 2, which gives us a positive 2. So we can go ahead and write our equation for the axis of symmetry, because it's x equals negative b over 2a, so we have x equals 2. Then for our vertex, that's the x-coordinate of our vertex. So now we actually need to take that value and plug it back in for x to find the y value of our vertex. So we have y is equal to negative 2 squared plus 4 times 2 minus 2. 2 squared is 4, so we have a negative 4. 4 times 2 is 8, and then minus 2. When we take negative 4 plus 8 minus 2, we get positive 2. So that is the y-coordinate of our vertex. Since our vertex shifted to the right 2, that's the horizontal shift. We went to the right 2 units, and it went up 2 units. And then for our x-intercepts, we actually need to solve for x. So what I want you to do, since you're masters at this now, is go ahead and pause, do the quadratic formula with a, b, and c, and then once you've found your 2 values of x, come and check back with me. When you complete a quadratic formula correctly, you should have gotten x is equal to plus or minus square root of 2. So for our x-intercepts, one of them will be 2 plus the square root of 2, comma 0, and the other will be 2 minus the square root of 2, comma 0. Our y-intercept is found by the coordinate point 0, c, which is negative 2. So now let's go ahead and graph. First we're going to plot the vertex, which is at 2, 2. And then I also want you to plot the axis of symmetry. Remember, that's going to be the vertical line that goes through our vertex. That's going to help us in graphing this one a little quicker. So we have our vertex, and then we have the y-intercept is 0, negative 2. So remember, we said the axis of symmetry acts as a line of reflection. So if this is 2 units over this way, we can plot this one 2 units over this way. Now we can go ahead and sketch our parabola. Hopefully yours is a little prettier than mine is. And now we can find the rest of our information on our chart. The domain is from negative infinity to positive infinity. The range goes from negative infinity up to positive 2. It is increasing from negative infinity up to 2. And it is decreasing from 2 to negative infinity. Now let's talk about intercept form. Now this looks like the factored form of our standard form, which it is. So let's talk about what A, P, and Q stand for. A is the same as before. If it's greater than 0 or positive, our parabola will open upwards. If it's less than 0 or negative, it's going to open downwards. If A is greater than 1, it's a vertical stretch. And if the absolute value of A is less than 1, it's a vertical compression. Our vertex is going to be the point P plus Q over 2, comma F of P plus Q over 2. And remember, F of P plus Q over 2 is the Y value when we substitute P plus Q over 2 in for X into the equation. The axis of symmetry is going to be the vertical line x equals P plus Q over 2. The x-intercepts are P comma 0 and Q comma 0. And the y-intercept is going to be 0 comma F of 0. So again, F of 0 is the Y value when we substitute 0 in for X into the equation. So let's go ahead and work out this example. First, let's find our vertex. Our vertex is going to be, we're going to need to find P plus Q over 2, which are our values here. So it's going to be negative 2 plus 2 over 2. Negative 2 plus 2 is 0. 0 divided by 2, or divided by anything, is 0. So the x-coordinate of our vertex is 0. Now to find the y-coordinate, we need to take this and plug it in for x, and then find the value of y. So we'll take y is equal to 0 minus 2 times 0 plus 2. 0 minus 2 is negative 2. 0 plus 2 is 2. So negative 2 times positive 2 is negative 4. So that is the coordinate point of our vertex. Then let's go ahead and find what other information we can. The vertical shift is going to be the up and down. It goes down 4 units. And our horizontal shift, there is none because it's still 0. And then for the axis of symmetry, it's going to be x equals p plus q over 2, which we found to be 0. And then we don't have an a, it's just 1, which means we have no stretch or compression. And then for our x-intercepts, remember, we have the x-intercept p0, which is going to be -2, 0, and then q0, which is 2, 0. And then our y-intercept is going to be found with the coordinate point 0, and then the y value when we substitute in 0 for x. Now it just happens to be that because we already found p plus q over 2, and that is 0, we've actually already done this. But if your p plus 2 over q is not equal to 0, you'll have to substitute in 0 again and do this a second time. So we've actually already done this, so it's the same. So let's go ahead and plot what we have so far. We have our vertex, which is at 0, -4. And remember, that gives us our axis of symmetry, which ends up being the y-axis. And then we can plot the x-intercepts, which is -2, 0 and 2, 0. And our y-intercept is our vertex, which we've already plotted. So then we can go ahead and sketch our parabola. And then we can fill in the rest of our chart. The domain, -infinity to +infinity. The range goes from -4 to +infinity. It is increasing from 0 to +infinity. And our parabola is decreasing from -infinity to 0. And that's it. I'll see you in class for some more practice.